Before it does beef skin. Okay, so this unit, everyone, is divided into two different parts, okay? The first part is about some types of calculations with formulas. So the whole unit is formulas, that's kind of the connecting piece. The first part is dealing with certain calculations on how a formula is actually determined. And then the second part is actually we're going to learn how to name covalent molecules and acids. So we've already learned ionics. That was back in Unit 2. We're going to review those again because those are the hardest. That's why we did them first. Okay, most of the time students actually really like covalent molecules because you're like, these are way easier. So hopefully that's how we'll feel, but we'll review the ionic ones because we still need to know how to name them. Okay, so the thing we're going to be focused on today is this thing known as percent composition. Okay, when I talk about percent composition, what it's talking about is it's the percentage by mass of each element in a compound. Okay. So my weird little analogy is this. Pretend that we as a class are a giant compound, okay? So each of you are an element, and together we make the compound of B5, okay? If we wanted to find the percent composition of Ben, okay, we would add up how much we all weigh together, and then we'd have the mass of Ben on top divided by the total to find the percent of Ben in the class. Okay, so that's kind of what we're going to be doing, except with a compound. This equation, you're either going to need to memorize, which is actually not too bad. It's just really finding a percent, or you could choose to put it on your note card, one of the two. Okay, so these are the steps we're going to take. First, like I said, you have to have a total. To find the percent of anything, you have to know what it's out of. Okay, so the first thing we do is we got to find the total mass, which the total mass is actually just the molar mass. So can somebody remind us, how do I find the molar mass? Jeff? Good. That's where we just go to the periodic table, we find all the individual masses, and add them up. Okay? So let's say, for example, we want to find the percent composition of copper 1 sulfide. So the first thing that we do is we need to find its total mass. So I look up on my periodic table. If you haven't yet, I would pull your periodic table out right now because we're going to be using it throughout the day, as well as I pull out a calculator because we're going to use that quite a bit as well. Calculator. All right, somebody look on their periodic table, and what is the molar mass of copper?
63.55.
Good. Remember, we just keep two decimal places. What do I do because there's a 2 here in the formula? Times by 2. Very good. So we're going to do 2 times that. Plus, we look up sulfur, which is 3201. 07? 07. Yeah, after rounding, right? 01, 07, close enough. All right, so add all that up for us, and what do we get as our grand total? That sounds good to me. 159.17 grams. Okay, so this is the total mass of our compound. Rachel?
Well, because of sig figs, would you have to round it up? Or is it because you're adding sig figs?
So remember, since we're adding, we go off the decimal. So since there's 2 after the decimal in each of these, our answer should still have 2 after the decimal.
Don't you times it beforehand?
We do, but the thing that we're timesing is an exact number, right? Because we know there's exactly 2, so we don't worry about sig figs in that case.
Okay.
Does that make sense?
Yeah.
Good question, though, and a good reminder, because adding is most often the one we don't do a lot of in chemistry, and so sometimes it's easy to forget that sig fig rule, okay? All right, so now that we have our total, our next step is we're going to divide the grams of an element by the total and then convert to a percent. Okay, anytime you're converting to a percent, that means you're timesing it by 100. Okay, so for example, this is written below, but I'm going to write it right here. So to find the percent of copper, we put the total mass on the bottom, and then we need to put the mass of copper on top. So what would that be?
127.
How'd you get that number, Jeff?
Look at the top, 63.55 times 2.
Yeah, so that's because there's 2 of them, so we still need to double it. What was the decimal place?
0.1.
0.1. Okay. All right. Oh, wait a minute. Should we keep the 0 this time? Because it's 4 sig figs.
So you got that from 2 times 6?
Yes, so 2 times 63.55 gave us the total amount of copper. Okay, and then that would times by 100, and we get what, 78?
79.
Oh, so you do each element separately.
What's our next decimal, Amy? Is that?
Oh.
It should be 79.851.
Oh, 851, sorry.
I had that wrong.
Yeah.
Yeah. I typed it.
That's okay.
All right, so then, if we want to find the percent of sulfur, we could do the same idea. So it's still the same total on the bottom. And then now it's just 32.07 on top, which gives us, times by 100. I'm going to plug that in. Anybody?
20.14.
Sounds about right. Any ideas how I technically could have found this?
So you just subtract that.
Yeah, okay. This is a really good idea, guys, to always kind of check your logic, okay? If we had gotten this to be 79, and then we did this calculation, and I got this to be like 50, that should be a big red flag that, whoa, something's wrong. Because these should add up to what? 100%. There is the possibility because of sig figs, it may be slightly off 100. Like it could be 100.06 or something like that. But if it's definitely way above 100 or way below it, you're missing something, or maybe you typed something in wrong. So it's a good idea just to kind of mentally look at the numbers and be like, oh yeah, that should add up to 100, just to double check everything. Okay? Yeah, Emily.
Let's round the 4 up to a 5.
Oh, thank you. Because the number after it.
You know, she's right. She's right.
Hey, way to be humble.
That's my bad.
Okay, let's have you guys try this problem for me. Okay, find the percent composition. Oh wait, that's what we just did. Psych. This one.
Do it again.
Okay, try this problem for me. Read the question carefully because the idea of it is still the same, but your approach is actually a little different based off what they've already given you. Okay, so read the question carefully and then find the percent composition of my iron and my oxygen in this compound, and then we'll check it together. All right, is everyone ready to check it? Okay, first off, what you need to recognize here, everyone. So with percent composition, we're going to be doing like 4 types of problems today. But they're all the same in that it's about percent composition, where it's a part over the whole times by 100. So in this problem, can somebody tell me why do I not go to the periodic table and actually use those numbers like we did before? Because it's given to us, right? They give us the masses. They actually don't give us the formula. So when you're given the masses, you actually just want to use that. So my total would simply be 36 grams because we add 28 plus 8. Then to find the percent of each of them, we take the amount, so there's 28 grams of iron to the total of 36 times by 100, that ends up being what, 78? 77.8. Wait, 77.78. Okay, so it actually would round up to 78%, since those are only 2 sig figs. Right, our answer would be 2 sig figs. And then the percent of oxygen, same thing, would be 8 over 36 times 100, which ends up being 22, right? After rounding? 22%. Okay, any questions on that? All right, if you got these correct, you can have 2 smiley faces. If you tried your very best, you can have what? Another type of problem, still about percent mass, but the approach is a little bit different. So when we read this question, it says how many grams of sulfur are in a 405 gram sample of copper 1 sulfide? So can somebody first off see why is this question different? What is our end goal we're trying to find now?
So we're trying to find percent, we're trying to find grams.
Yeah, we're not trying to find the percent. We know the percent. We want to find the original, how much it was. Okay? So any ideas of how we would go about this? Yeah.
Times, so you multiply 405 by 5%.
Perfect. So we know the total is 405. So all we do if we want to find an amount is we take the total and we're going to times it by the percent. But what do I have to do with the percent first?
5 by 100.
I have to change it back to a decimal, right? So we would times it by 0.2015, right? Divided by 100 or move the decimal 2. So you take the total and then times the total by the percent as a decimal. And that's how we do every single time. You can have a smiley face for that, Trey. What do we get here?
81.6 grams.
81.6 grams
Of sulfur.
of sulfur. Thank you. Is this answer logical?
Yeah.
Does it make sense? Because what were we trying to find?
Grams of sulfur.
We were trying to find 20% of 405. That is a logical number, right? If this would have been, let's say this was like 800, would that be a good choice? No, because 800 is not 20% of 400, right? So it's always good to do just a quick logic check on your answer and be like, does this make sense? Because a lot of times you can save yourself from maybe you just type something in wrong your calculator. And rather than writing it down, you can fix it ahead of time. Okay? All right. So our last part of percent composition that we need to talk about are these things called hydrates. Okay? So what a hydrate is it's an ionic compound that has a specific number of water molecules attached or associated with it. Okay? The way that we represent it is like this. Okay, this is calcium chloride dihydrate. There's this dot in between. It's not so much like a dot, like a times symbol. This is just the notation that they use for a hydrate. Okay? Yeah. Okay? So the key thing is that it's specific. For this one, there's 2 waters trapped in the middle. You could have more. I've seen a decahydrate, which would be 10 waters trapped in the middle, right? Just depends on what it is. All right, so let's try a problem with a hydrate now. So we want to find the mass percent of just the water in our calcium chloride dihydrate. So what did we say is the first thing we have to do to find a percent composition? We gotta find the total mass, okay? So let's add up our total. So I look on the periodic table and I find calcium, 40.08.
That's why they did
Okay.
Hey, we have an egg.
Okay, then we got chlorine in there, so 35.45, and I gotta times that one by 2 because of the 2. So now you have options. We need to add the mass of the water because it's in there. It's part of the weight. So you could do it 2 ways. You could break it apart and say, how many total hydrogens do I have here? So there's a 2 here, but since there's a 2 out in front, it actually would be 4 total. The other approach, which actually is what I prefer, is we could just do, okay, well I know there's 2, and does anybody remember the molar mass of water? Because we have calculated a few times.
18.02.
Yeah, so you actually could just do 2 times 18.02, because that is how much a water molecule weighs altogether. So rather than breaking it down into hydrogen and oxygen, we can just take it as a whole, which will save you a little bit of time too. Okay, bless you.
Is that molar mass on here? Or?
No, you just calculate it by taking, so 2 hydrogens plus an oxygen is 18.02.
Okay.
So, question, Haley?
Okay, so what would it look like if you
Okay, so the other approach would be, so that's all the same, right? So then the other approach would be, so I'd do 4 times 1.01 for the hydrogen, plus 2 times 16.00 for the oxygen.
Oh, so does that big 2 go with the oxygen as well?
A number out in front goes to both. Yeah, it's kind of like almost like parentheses.
Okay.
So, yep, and either approach you should still get the same answer.
Okay.
So, all right, so when we plug that all in, what do we get as our total?
147.02.
147.02. Do I have a second witness to that? All right. Okay, so now we have our total. Now this question wants us just to find the percent of water. We don't have to find all the other pieces just because that's what the question is asking.
18.02 over.
So we got to do 2 times 18.02 on top because there's 2 waters, right? And you can times that out before, and then over our total, 0.02 grams, and then times it by 100. So the total amount of the water divided by the total mass of the compound. Yeah, Malia. No. All right, what do we get when we plug that in? 45? No.
24.
24.5? Is that what I heard?
Wait, why did you only put these?
Because somebody only said, I didn't know what the next word was.
24.51.
It's
24.51.
There you go.
Okay.
Oh.
Okay, questions on that? So, tell me this. If I were to heat up this compound and evaporate all the water, how much weight would it lose?
24.51%.
Yeah, that much of it, right? Almost 25% of it would go away just by heating it up.
I can't even like laugh.
Questions on this problem? How we get the answer?
How do we label it? Like the end? Is it just with what the percentage we're finding?
Yeah, so just be percent of water in this case.
Six.
Yeah, good question. Okay,